Wrapping up this video on 14.7 day 3, we have one last boundary to check, and that's this diagonal, or I should say the hypotenuse of this right triangle, pardon me, segment AB. And as we look at segment AB, we are really looking at the equation y equals 9 minus x. That means as we come back up to f of x, what we're really doing is we're saying everywhere where there's a y, replace that with 9 minus x. And you can see you're going to get a brand new equation exclusively in terms of x right now. And we're going to really try to find where on this boundary of AB there might be some critical numbers to check here. So let's take a bit of time to combine some like terms. Distribute this 2, we'll get 18 minus 2x. 9 minus x squared would be 81, and then a minus an 18x plus x squared, but of course we have to distribute that negative everywhere in there. And I think you can see a 2x and a minus 2x will actually cancel out. We'll have a negative x squared and a negative x squared. That will become a negative 2x squared. And then we've got an 18x. We've got that right there. Now a 2 and an 18 make 20, and 20 minus 18 is negative 61. So that's what we are dealing with. If we took our derivative, we'd get negative 4x plus 18. If I were to set that equal to 0, and if I were to solve, I'd get 4x equals 18. X would be 18 over 4, which is really 9 over 2. But please remember that your y coordinate is on the line y equals 9 minus x. So if I had 9 minus 9 halves, that's 18 over 2, minus 9 over 2 is another 9 over 2. So what we're really trying to figure out is what is happening with our function at the point 9 over 2, 9 over 2. In other words, 4 and a half, 4 and a half. Now, we have 2 plus 2x plus 2y minus x squared minus y squared. Of course, we can get our calculator in there, and I actually did that in class just a little while ago. I plugged in 9 over 2, which is 4.5, into this equation. Take it from here, you can confirm yourself that the function value is negative 20.5. So we're also going to have to ask ourselves if we need to go back to this segment AB, 4 and a half and 4 and a half, that would be right here. Please understand the endpoints at 9, 0, and 0, comma 9 have already been checked. That's really, really cool that, we don't even have to go about searching for any, further endpoints. Those endpoints were taken care of in our previous boundaries. So let's revisit all of these endpoints and critical points that we have been addressing. You can see that we've got a number of them. And what we can see is we very quickly see that the largest x value ever present, the biggest, is a 4. So we can say we've got an absolute max of 4 at the point 1, comma 1. The absolute minimum, well, that's negative 61. And it actually occurs at 2 ordered pairs, at 9, comma 0 and at 0, comma 9. So that's actually our answer. you have to investigate boundaries carefully. You have to really just make sure you're checking the endpoints and where the derivative on that boundary might equal 0. So it's a lot of checking. It gets to be a little tedious, but hopefully that makes sense. Best of luck.